Okay, so let's consider this example here. X squared minus 9x minus 5 over x times x squared plus x plus 8. So the denominator is already partially broken up. We do want to check to see if we can break this one up. So before I even think about factoring or anything like that, I just go to my discriminant, b squared minus 4ac, right, check to see, is this thing going to be able to be factored? Well, b squared will be 1 squared minus 4 times 1 times 8. It's going to be 1 minus 32, negative 31, that's negative. And so I actually know this quadratic cannot be factored across real numbers. So it's what we call an irreducible quadratic factor. So it's going to stay as an x squared form. So in this case, I have a linear factor and this quadratic factor. Okay, so the decomposition is for each linear factor, write it down as a constant over that factor. And for the quadratic factors, since it's second degree, we need a linear factor on top. So bx plus c all over x squared plus x plus 8. So that's the setup. And then we're going to multiply by the LCD. So on the left-hand side, everything will cancel out. And we just get x squared minus 9x minus 5. On the right-hand side, we're going to have a, well, the x will cancel out, times that denominator. So in other words, a times x squared plus x plus 8. That'll give me ax squared plus ax plus 8a. And then the x squared plus x plus 8 will cancel out, leaving you with an x to go with the bx and the c. So times x, that'll be bx squared plus cx. And now we're ready to go through and start equating coefficients. So up first I have an x squared, I have an ax squared, and a bx squared. So that's going to produce an equation for me there. A plus b is going to have to be equal to 1. Go to my x terms. I have a 9x. I also have an ax and a cx. So I'm going to have an equation a plus c equals negative 9. And then last but not least, I have a minus 5 here, and I have an 8a. So as I start to deal with this system, I immediately realize, hey, I can find a right off the bat. So I do that first. I'm going to do that one first. 8a equals minus 5. So a is a negative 5/8. We'll then work our way through and try to find the other two variables. So going to the red equation here, a plus c has to be negative 9. A plus c has to be negative 9. We know a is negative 5/8 plus c equals negative 9. If we got a common denominator, negative 9 would be negative 72 over 8. And we add 5/8 onto that, so we get c equals a negative 67 over 8. And we know a, and we know c. We just need to figure out b. So we go back up to our equation here. A plus b has to be 1. A plus b is equal to 1. A is a negative 5/8 plus b equals 1. So we would add that over. That would be 1 and 5/8, which would be 13 over 8. Okay. 13 over 8. And so now we know what b is. So we know all of our constants. So now we just put them back in and may need to do a little bit of housekeeping, a little bit of cleaning up. But other than that, we're ready to pretty much write our answer just about. Okay, so we go back up here, replace A, B, and C with what we found them to be. And let's just go ahead and do that and see what else we need to do. So A is a negative 5/8. So that's going to be negative 5/8 over x. And then plus bx, 13 over 8x minus 67 over 8. All of that divided by x squared plus x plus 8. And then there's just a little tiny bit of housekeeping we can do here. And that is, we don't want to keep these as complex fractions. So I'm going to take that 8, the first one, and move it down to go with the x. And for the second one, I'm going to factor out that 8, 1/8, and put it in the bottom. So I'm going to have 8 times x squared plus x plus 8. And on the top, I'll just have 13x minus 67. 13x minus 67. Okay. So we're going to stop here. We're going to stop here in this example at this point. So far we have seen just regular linear factors. We've seen a repeated linear factor. We've now seen a linear factor and a quadratic factor. The only thing we haven't looked at yet is a situation where we have a repeated quadratic factor. And that's actually going to come up in the next example.